What's up? I'm gonna be doing week 6A homework on momentum. Having a little bit of camera problems right now. But to begin, we're gonna do a little simple question. Where would you expect the center of mass of a baseball bat to be located? Halfway between the ends of the bat, near the lighter end, near the heavier end. So in this situation, oops, we're gonna obviously have the baseball bat. If I could get a drawing here, looks about like this. Gets a little skinnier. So obviously this would be the lighter part in this situation. Let's just say 2 pounds, 2 kilograms. Made up numbers, it's okay. 2 kilograms. This heavier end would be about 10 kilograms. In this situation, the baseball bat has more mass in the barrel than it does in the handle. So the mass isn't distributed evenly. The heavier side is going to pull the center of the mass towards it. A good example I heard someone say was, it's where you can balance an item on your finger. You can't balance it here, right? If you were to put your finger right here, it'd obviously tilt to the right. But if you would put your finger right about here, then because this has so much more mass, all this mass over here would equal to this side. So it would be able to balance. So the center of mass would be somewhere around here, maybe over here, one of these 2 points or in between even. It's just more towards the heavier side because the heavier side is pulling the center of mass towards it. So obviously it'd be near the heavier end. I like that question. It's something simple, something quick. For my next question, we're going to change it up. We're going to do question 4 here. So okay. 2 friends, Al and Joe, have combined mass of 178 kilograms. At an ice skating rink, they stand close together on skates, at rest, and facing each other with a compressed spring between them. The spring is kept from pushing them apart because they are holding each other. When they release their arms, Al moves off in one direction at a speed of 0.606 meters per second, while Joe moves off in the opposite direction at a speed of 0.863 meters per second. Assuming that the friction is negligible, find Al's mass. So, what we're trying to find here is Al's mass. So let's just do MA. And this is the unknown. It's going to be in kilograms. The SI units of his mass is going to be kilograms. And we have also MJ, which is Joe's mass, in kilograms also. We also have the velocity of Al. And the velocity is going to have an SI units of meters per second. It's going to be 0.606 meters per second. And we also have Joe's mass, Joe's velocity. So in this situation, we're going to have 0.863 meters per second. And the SI units of the velocity is going to be meters per second. And we also have the total mass of both of them being 178 kilograms. And this is what we have so far. We also have, let's just make a drawing here. They're both together and they push off of each other. Not a very good drawing, but we ball. So he's going this way, he's going this way. And let's assume this is Al and this is Joe. And Al is moving at 0.606 meters per second, while Joe is moving at 0.863 meters per second. Both of them have a combined mass of 178 kilograms. So in this situation, we're looking at momentum here, right? So when we look at momentum, we have the equation P equals mv. Momentum equals mass velocity. And the SI units for momentum real quick is going to be kilograms times meters per second. And the initial momentum in this situation is going to be 0 because they're at a standstill, right? They're both together. Nothing's moving. Nothing's happening. And they have an equal magnitude in which they get forced off of each other because they're both in the same position with that spring in the middle of them. As soon as they let go, boom, equal magnitude of force in both ways. It's just a mass affecting it. So because they have equal magnitudes, the mass of Al times the velocity of Al is going to be equal the mass of Joe times the velocity of Joe. And we know that the mass of Al plus the mass of Joe is equal to 178 kilograms. So we have that. If we rewrite this equation right here, we can get mj equals 178 minus ma. And then what we're going to do is we're going to use this equation right here that we have with this. We're going to plug in the 178 minus ma, and we're going to have the mass of Al times 0.606 is equal to 178 minus ma, mass of Al, times 0.863, the velocity of Joe. And if we just keep on solving here, we're going to get 0.606 mass of Al is equal to 153.614 minus 0.863 mass of Al. Because we distributed this right here, we distributed the 0.863. And then we're going to have 0.606 mass of Al. Since we want to get this mass of Al to this side, we want to keep both masses of Al on the same side. We're going to do mass 0.606 ma plus 0.863 ma is equal to 153.614. And then we're going to add these up together. 1.469 mass of Al is equal to 153.614. Then we switch these two and we divide each other with m of a equal to 153.614 because we divided these by 1.469. 1.469. So this is going to be divided by 1.469, which is going to equal 104.6 kilograms. And that is the final answer. That is going to be the mass of Al. And yeah, that's going to be my 2 questions for week 6A homework momentum.